In part 2 of this video, we'll be looking at salt analysis. Like I said earlier, like I earlier mentioned, that Xn contains Zn as the salt, which I told you earlier is insoluble. And then Yn is AlCl3, which I told you was a soluble salt. On the right hand side of the board, salt analysis is better represented in tabular form under the subheadings: tests, observation, inference. On that note, as the table, so we are looking at, first of all, look at what Xn is. X, you just call it X for the N, because you don't have it as a candidate. It's just X is per candidate, N is for numerous candidates. X, the matter state of X is solid. Make sure you represent it. Plus 5 cm, say 5 cm cube of distilled water plus stir. Stir means shake to see if the salt will dissolve. Okay, since X is zinc carbonate, all carbonate salts are insoluble in water except those of group 1 and ammonium. So zinc is not a group 1 element, so you don't expect the salts to be soluble. So zinc salts are insoluble most often with carbonates. So I'm going to write it here. Every statement you made here will score you. The time you added 5 cm of distilled water to X, what happened? It does not dissolve very well. So you write it partial dissolution. Yes, partially dissolves distilled water. So, okay. This is what it is. So you can say plus, litmus paper or indicator paper. Remember there are 2 indicator paper, red and blue. So since the salt is ZnCl3, so it's a salt of weak base, weak acid. So basically it will be so neutral with litmus. So with litmus paper, no effects. No, that is under here, make sure they are aligned. No effects on blue and red litmus paper. Okay, when you have salt partially dissolved in distilled water, what does it tell you? It means that X is an insoluble salt, having not dissolved. No effect on blue and red. What does it tell you? It means that X is neutral salts. Okay, that is on that question. Okay, then whatever you're going to answer in the next question will be now what you have here. So now this X now is solution X now, because it's now in solution, not going to be solid. Solution X plus. The only thing I'm going to do here is just I'm testing for 2 things here. One is zinc ion, the other one is CO3 2 minus. Let me start with this test. Whenever I want to test for cation, I always test with NaOH aqueous. Okay, what is going to happen in drops is different from what's going to happen in excess. Of it. Okay, under the drops, what do you see? It is what? White gelatinous precipitates formed. That is under in drops. In excess, I'll make sure it's in alignment. In excess, In excess, I have that. Precipitates, soluble in excess of the reagents. So what I'm having here now is two reports now. In drop, I have this. In excess, I have this. So in drop, you should know that there are three cations apart from zinc that also show white precipitate and also precipitate with silver oxide. One is aluminium, apart from zinc. The other one is lead ion. So three of them will appear here. So here I'm going to have to suspect this man, and then this man. So these are present here. So since three of them are amphoteric, so you also see how to, because amphoteric means that they are now based the analysis. So that means they can dissolve here. So three of them which will dissolve here. So being soluble, so yeah, they are still going to appear here as Zn 2 plus, Pb 2 plus, Al 3 plus, and present at the same time. So this is what you have at this point in time. So whenever you see this on X, this is exactly what it's going to be. The observation, and this is going to be the inference. Okay, the one more thing we're going to do is to look. Okay, before we test for this, I think we're still going to have more on here. So we're going to keep this into three solutions. Maybe this is the first solution of X. That's going to be the second solution of X. So another solution of X, we're going to separate it into three now. Another solution of X, solution of X again. Let's keep it in three. This in plus NH3 in drops here in excess. What happens in drop? What happens in excess? So in drops now, you're still going to have white precipitates. I don't think it's going to be gelatinous. Yeah, it's okay. It's going to be because it's okay. White gelatinous precipitates. White gelatinous precipitates. Okay, that is what happened in drop. Then in excess, precipitates soluble in excess. So the same 3 O thing is going to come out in drop, which is still zinc, lead, aluminium. All are present at this point. But here, because the out of the 3 of them, zinc is the only transitional. That's the log element. So it's going to form complexes with the ammonia. So in that case here, you have to confirm this one. Zinc confirmed at this point in time. Okay. Now this is an analysis. Then the last. No, we need keeping the solution into 3. First solution from here, plus solution on the side. Second solution from here, plus ammonia, both in drop in excess. Then the last one will be. So now, the last solution of X plus dilute HCl, aqueous. Okay, in this case, you're going to score this way. First of all, because you are testing for gas, you're really going to see what they call it effervescence occur. So once you study this, you're going to have your mark. Colorless, odorless gas evolved. Colon. You have your mark. Tons, wet, indicator, paper, red, another mark, tons, lime, water, milky, another point. So you have just made 4 points here. Effervescent occurs, that is bubble, 1 mark. Colorless, odorless gas evolve, 1 mark. Tons, wet, indicator paper, red, 1 mark. Tons, lime, water, milky, another mark. Okay, so there's going to end mark here. Don't end mark in text. Only end mark in observation and inferences. Once your inferences are wrong, that means you don't have good observation. So now, coming to the inference now, what do you infer? You will infer. We already know this. You will infer that first of all, gas is acidic. That's 1 point. CO2 from, cannot come from anywhere, it can't come from specific source. From CO3 2 minus or HCO3 minus present. That's what you do in that aspect. That is what you do for X. Because there are two salts, that is zinc carbonate and aluminum chloride. And it went straight to call an aluminum chloride Y. We went straight to carry out test on Y, and that is the tests for salt analysis there. So that's what you see in X. So in that, summarily, now could now say that X contains, since you confirm zinc here, so X contains Zn 2 plus CO3 2 minus. So you should know with this inference, you should already know that that's salt, even though you didn't know that it's the salt from what you have seen here. X is zinc carbonate, because that's what is playing out there. So we go straight to Y, which is aluminum chloride. For the next salt, we have Y. Matter said this is solid loss 5 centimeter cube of distilled water plus sheep. Okay, what do you observe? Dissolves. 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 Dissolves to give colorless solution. Okay. And then when we add litmus to it, litmus paper, the resultant mixture. Now look at it. Look at it. AlCl3. Okay. This is salt from aluminium chloride, possibly, and HCl. So this is going to be weak base. This is going to be strong acid. So this is an acidic. That's why it's called Lewis acid. So it's going to be more of acidic salt. So you know what it's going to do to litmus paper. Okay. As this is for litmus paper. Now it must have effect on blue. Yes. Here, tons blue litmus paper red, and then no effects on red litmus paper. So when it dissolves, what do you write for the dissolution there? It dissolves. Y is soluble salt. Y is soluble salt. When it turns, because it turns blue litmus paper red, you can say Y is acidic. Y is acidic. Okay, that's what you do there in that question. So, like we previously, these are going to come in the same table. Okay, after X, this is Y. You're just testing for this and this. Okay, but I'm going to start with Cl. So we're going to have the solution into 2 or 3, into 2 or 3. Okay, that means whatever thing I have here now will be a solution now. So it will now be solution Y plus HNO3 aqueous plus AgNO3 aqueous plus NH3 aqueous. Should make sure all these things are going to be in alignment. So here, to get rid of interfering ions, HNO3 here, no PPT or no visible change here. No visible change. You don't see any precipitate as well. So there's no change here. So here should be black. So when you add this silver nitrate here. Here we have white precipitate. It's not gelatinous this time. Precipitates. White precipitates. Because of this white precipitate here, under here is Cl minus present at this point. Cl minus present. Now we add this precipitate here. Precipitate dissolves. It will not persist, dissolves. So the dissolved precipitates confirm that Cl minus is present. So that will be a confirmatory test there. So we are quite well confirm this. So that is what it is. So see, all this is in alignment. So make sure solution Y plus this, there is no reaction, so there is no inference. With this, it's a Y PPT, with this there is this. So make sure it is in good alignment. Okay, and then finally, you have the last solution now. Solution Y plus NaOH aqueous in drops goes in excess. So what do you have here? Okay, white, because it's aluminium, we're testing, so it's in the form gelatinous precipitates. That's aluminium hydroxide, which is amphoteric. White gelatinous precipitates. White gelatinous precipitates. That is what is actually in drop. Then precipitate there. Precipitates, because it's amphoteric, precipitates soluble in excess. So what we hear will be Zn 2 plus, Al 3 plus, Pb 2 plus present. Actually, they are all amphoteric. So dissolution of this, so shortly also coming in 2 plus, Al 3 plus, Pb 2 plus are actually present. Okay, so but actually we are going to be looking at aluminium this time. So at that point, we are going to do a test with ammonia. So I'm going to use this space. Now you know you're going to be keeping so many solutions for all these tests. So having tested solution Y from the first part. So we also have another solution Y plus NH3 in drops and what? In excess. Y. So okay, in drops you're going to also see your white gelatinous precipitates. That is what happened in drops. So in excess, precipitate because it is aluminium, not zinc, precipitates insoluble in excess. So you should know that you have to, all the precipitate is formed, you should also have Zn 2 plus, Pb 2 plus, Al 3 plus present. But actually zinc is not going to be there again because zinc will be soluble if it is zinc in excess of ammonia. So take away zinc, you're going to have Pb 2 plus and aluminium plus. I think this one, let me use suspected. I'm not suspecting. I've already confirmed that zinc is not even close to the salt Y. So have these two persons now. Okay, but I'm still going to know whether it is this or this. That will be my next test. Whether it is lead or aluminium. Keep on the solution Y plus dilutes HCl. Okay, there is something you must know about lead salts. Yes, something you must know about lead salts, which is that all chloride salts are soluble in water except those of lead, not only lead, mercury, and silver. So when you have lead salt now plus HCl, it's going to give you lead chloride plus H2. This is not soluble, it's insoluble. So this is going to be a white precipitate. But if you have aluminium salts plus HCl, you're going to have AlCl3. Okay? So 3 goes there, I think plus H2. Okay, I think it would be 6. Okay, to be 6 always. Okay, this will be plus a loss. Sorry, 2H plus. Okay. Okay, 3H minus. Okay, so in this case now, this is soluble, this is insoluble. So now, that means if it is lead, which it is not lead, because we already told you the salts, it will form a white precipitate with ACl. But it's not lead. So with this, there won't be any there's no precipitates. No precipitates. If you add this with this, no precipitates. Okay, so but if it will give you white precipitate. So since addition of this with this here, no precipitates form. Should it be this or this? Actually, it is confirmed that Al3 plus. Confirm, but at this point, there are so many ways to confirm this, but at this is the level we can go as far as Neco is concerned. So there is no provision for so many things you can use to verify whether the salt is aluminum, but it's the information given on the white paper, it should be with ACl. But if it is actually lead, but we are not dealing with lead in this exam, actually there will be a white precipitate, which on cooling it does this, on cooling it does this, on heating. So, but that is not going to be, so there's not going to be much heat on this issue. But even if you heat, there will still going to be, because there's no want to confuse the student to look as if it is going to be lead, so they may ask to warm. Even if you add warm or heat, the reaction still remains no visible change, no precipitate. So that should be telling you that aluminium is what is confirmed. So at the end, conclusively, X contains cations having confirmed chloride and having confirmed aluminium. So that's why contains is a salt of aluminium and then chlorine. So you can call it there, you can summarize as the salt is chloride salt of aluminium, the other X is carbonate salt of zinc. So that is what it is. These are SSC in Neco exam. So you watch the video several times to get acquainted to some of these things. And I wish you all the best in the exam. Thank you for watching.